All right, today we are going to learn how to calculate the percent composition of elements in a compound by mass. So first we'll talk about problems where you are given a chemical formula of a compound and asked to calculate the percent composition of the elements in that compound by mass. And then second, we will talk about how to calculate the percent composition of elements when you're given experimental data. All right, so before we start getting into specifics here, I just want you to remember that you know already how to calculate a percentage of something. So to calculate the percentage of something, you need to know the part of the whole, and then you need to multiply that by 100. So for example, if you know that there are 4 boys in a class of 8, so the part would be 4, and the total would be 8 people. And then, of course, if you multiply 100, then you end up with 50%. So you would say 50% of that class is boys. So that's how you calculate a percentage, and the same would be true in chemistry. So we're going to need this little equation. So I'm going to move that up there. All right, so here's an example of a question you might be asked. I want to know the percent composition of each element in water. Now, before we get too far, I should explain to you that whenever I say percent composition, I mean by mass. So what I'm not looking for is percent by number of elements. I'm looking for percent by mass. So to solve a percent by mass problem, you need to have a mass. And so in this case, we're just going to use the molar mass. All right, so the molar mass of water is 18.015 grams. And that's going to be your whole in this equation right here. So that's how much water would weigh, 1 mole of water would weigh, 18.015 grams. Okay, the second thing we're going to do is we're going to figure out how much of this total mass here is due to the hydrogens and how much is due to the oxygens. So for the hydrogens, in this compound, H2O, there are 2 hydrogens present in the formula. So the molar mass of one hydrogen is 1.08 grams, 1.008 grams. We'll multiply that by 2, and that means that there are 2.016 grams of hydrogen in this 18.015 grams. And for the oxygen, there's only 1 oxygen in the compound, and its molar mass would be 15.99 grams. So we know the 2 parts, so these should add up roughly to 18.015 grams. So we know our parts for hydrogen and our part that's oxygen, and we know the whole is 18.015 grams. All right, so we're going to divide each part by the whole to get our our percent. So our percent hydrogen is going to be that 2.016 grams divided by 18.015 grams times 100, and we get a percentage of about 11% hydrogen. And our percent oxygen by mass is going to be 15.999 grams divided by the 18.015 total mass times 100. You get an 89% of oxygen. So that means by mass, no matter how much water I have, if I know the mass of the water sample, 11% of that comes from hydrogens and 89% comes from oxygen. So I'll move it up and we'll do another example. All right, so the second example, I just want to know the percent composition of the elements in Na2SO4 sodium sulfate. So step number 1 is to calculate the molar mass of sodium sulfate. So when I do that, the molar mass that I get is 142.041 grams per mole. Great. Now we need to find the mass of each part. And there are 2 sodiums in our compound, and Each one weighs 22.990 grams per mole, and so that's a total of 45.98 grams of sodium. There is one sulfur in our compound, and it weighs 32.065 grams per mole. And there are 4 oxygens in the compound, and they each weigh 15.999 grams per mole, so that gives us a total of 63.996 grams for the oxygens. So our 3 parts are the 45.98 grams of sodium, the 32.065 grams of sulfur, and the 63.996 grams of oxygen. So the last thing we'll do is we'll calculate the percentages. So for sodium, 45.98 grams of sodium in 142.041 grams for the total mass times 100 gives you a 32% composition sodium. The percent of sulfur, 32.065 grams divided by 142.041 grams multiplied by 100 gives you about a 23% on your sulfur. And then lastly, we'll do the percent of oxygen. And your percent of oxygen turns out to be 45%. Now, I always like to take my percents and just add them up and make sure that they add up to 100, which these ones do. All right, the second half of this video, we are going to talk about how to calculate the percent composition of the elements in a compound based on some experimental data. So in this case, we don't know the chemical formula of the compound. What we do know is that we have some amount of the compound and we've chemically separated its parts, meaning that we took it and broke it into the elements that it's made of. And we know the mass data on those elements, or the mass data on some of the elements and the total of the compound. And we're just going to use that data to calculate percent composition. It actually sounds a lot harder than it is. So I drew a little picture of what we've got going on here. So we're told we have a 12.2 gram sample of some compound. So here's that compound. And it's separated into its parts, which happen to be 5.2 grams of chlorine, and then the rest is sodium. And we're asked to find the percent composition of each of the elements in this compound. And so the first thing we need to do is figure out how much sodium we have in this compound, which should be relatively simple if you consider the fact that this total compound is made of 2 things, 5.2 grams of chlorine, some amount of sodium, and that's all going to add up to 12.2 grams total. So law of conservation of mass or matter says that your 2 parts have to add up to the whole. Great. So that being said, we can just take the 12.2 grams of our total and subtract the 5.2 grams of chlorine, and that's going to give us the mass on our sodium, which happens to be 7.0 grams of sodium. So from there, then percentages become super simple. So for the chlorine, we know that of the 12.2 grams, 5.2 of those are chlorine, and so 5.2 divided by 12.2 multiplied by 100 gives you 43% chlorine. And then the percent on the sodium, we just determined that 7 grams is sodium out of the 12.2 gram total. Multiply that by 100 and you get 57% sodium. So there's your percents of each of these elements in this compound based on mass data. All right, here's another question that's based on percentage and percent composition. This one's a little tougher, but I have confidence that you can answer this question. So you're told that you have a compound and that 8.2 grams of that compound is magnesium, and you're given the percent of the magnesium as well. and you're told the compound contains oxygen as well as magnesium, and they want the mass of the oxygen in the compound. Seems way more confusing than it is. I promise it's really easy. So we know this compound is made of magnesium and oxygen, and we know that we can set up a little equation to help us solve this problem. So we're given the mass of the magnesium, we don't know the mass of the oxygen, and we don't know the total mass, but we do know the percent by mass of magnesium. So we know that 60.3% of this compound is magnesium, and we know that 8.20 grams is magnesium. We don't know the total mass, and we know that to make that into this percentage, we'd have to multiply by 100. So we're going to solve for the total mass using this information. All right, so to solve for x total, we have to get it over here. So we're going to multiply both sides by x total. And then we're going to divide out 60.3% from both sides. And then that will give us our x total. So x total becomes 8.20 divided by 60.3 times 100. And that is 13.60 grams total. So up here we can put 13.60 grams. And then of course, if we know that 8.2 plus this mass of oxygen equals 13.60 grams, doing some very simple math, we figure out that the grams of oxygen is 5.40 grams. And then from here, if you wanted to calculate the percent of oxygen, you could. So that brings us to the end of my fun little tutorial on percent composition by mass.